that the right one, Simba? I think it's not, but anyway.
What was the render command again?
Okay, are we live? I think we are live. So welcome to the 3D print event, Ceramic 3D Print Hack. This is part of the Fak'ugesi festival. And if you're joining us online, we just want to welcome you and give you an overview of what we're trying to do. We have built our own ceramic 3D printer. It prints clay, 3D printer parts, the easy parts. It's very well documented. It's easy to build your own 3D printer. Easy in that if you can follow instructions, you can build your own printer. What is not easy is extruding clay in a reliable and consistent way, because that is not documented. No one has explained exactly how to do that. There are some sort of ideas out there, and there are some general, you can look at pictures, but where we found it's been 2.5 years of development to get to a point that we can reliably print clay. So what we are trying to do is to reach out to designers and to create a platform for people who want to make their own products out of ceramic materials or ceramic medium. And you'll see on the side of the screen, the 3D printer is busy starting a print, and it's going to print throughout the event. So hopefully some of what we see on the screen will transform into something physical. As far as the flow for the night goes, or the evening goes, the outcome is for you to create your own object out of clay that will then be fired and glazed according to your requirements. And so we want to help you get to that point. We are assuming that you have some level of design capability and skills. And if you don't, then you'll have to be working with a designer to help you realize your idea. And so, yeah, we're hoping to have some fun and to create some new objects in the world. So I'm going to hand over to Sam Katsun, who's going to do a brief overview and introduction. And I will also help her fill in some of the blanks in her presentation. So Sam, are you ready to go? Okay, Sam's going to share his screen. Okay.
Can you guys hear me? Okay. So I'll be giving you a quick run through on essentially what is clay 3D printing and the process that we have to go through in order to make these ceramic printed objects, and just how you can also participate and make your own object. So now I'm going to just share my screen just quickly. I'll be just referencing this, yeah. Okay, I'll scroll through because we've already introduced it. So when it comes to ceramic 3D printing, it works in a similar way that you would think of if you've ever done any sort of 3D printing. It's essentially extruding a medium through a nozzle, which then creates a 3D form from geometry that you've previously created using a 3D software. So in our case, what we're using is clay, which is a medium can sometimes work in its own way. It's different to plastic printing in the sense that, Okay, it's different from plastic printing in the sense that we're not heating up the material, and the material sort of extrudes in a form where it's wet for most of the time. So that's something that we need to consider throughout the process, is the fact that when printing, the material will do its own sort of like thing. Instead of like hardening as it's being printed, I think you can see from the video and like some of the footage that we're going to show you guys is that it doesn't always work in the way that you think it would. But what we're trying to do is actually guide you through the process, which can then help you create 3D forms that are going to be sort of viable or have the best results in terms of printing clay. Okay, so what we are going to do next is try and give you guys an understanding of the medium of clay. As I said, the medium of clay is not a medium that hardens as you're printing. So you will have to think about the fact that when you're printing an object, the consistency of the clay that you're using has a huge effect in how the product will actually come out. So how high or how like wide you have your object or whatever it is that you've designed will ultimately affect how your print turns out. Sometimes you can use that as part of your design. I'll show you just some examples after we've done a short presentation on how you can actually use some of the ways in which your design fails while printing in order to create like a new form in a sense. So the process is actually just like a lot of trial and error. You're gonna have to print a couple of times sometimes in order to get like the best results, because it's not always like a straightforward type of printing in the way that a polymer type of printing would be. So like there's certain factors that can affect your print during the printing process and the design process. So in the design process, you can have certain heights and like width and angle restrictions for whatever it is that you're designing, which can help you have the best results in terms of your print. And in terms of the medium itself of clay, you have to be very considerate about the consistency that you make it. But that is going to be something that we, as the MakerSpace and the ceramic 3D printers, will be concerned about more in terms of like getting clay that is at the right consistency. I don't know if you have any clay sculptors or anything like that, but you know that when you get clay, it comes in a hardened form. But then what we have to do is actually add quite a bit more water in order for it to extrude in the way that it extrudes in the demo that it is, that we're still printing right now. And you know, it also is a medium that changes over time. So the moisture will sort of change, or like the amount of moisture will change throughout the time from which you print it until the time you have to like glaze it and fire it. So something to also consider is the fact that if you want something that's going to be about 200 mils high by 200 wide, you will have to consider the fact that the clay will shrink by about 13%, which will then alter your design. But like if you consider it ahead of time, you can actually have the exact same results that you wanted to have. I don't know if you have any questions as of yet, or any input. But I'll carry on just now. So I think you can see feed from the printer itself. The printer itself has some constraints that we need to also think about, which is the actual size of the printer. We can't print above a certain height, and we can't print over a certain width per se. So these are some of the constraints that we have to constantly think about when we're trying to design something. But I'll just quickly run through them. They're on your screen right now. It can't go over a height that's about 450. So if you're making a vase, you have to consider the fact that it can't be too tall or too wide, which is about, above 240 in width and depth. Okay, and as well, we have different size nozzles. So the nozzle is the end parts of the machine, or the printer, which is what extrudes the clay at a certain width. So this is the nozzle size that we're going to be working with right now, which is the 2.5 nozzle. You can get larger nozzles, which give you different results in terms of like the width and in terms of like how high each layer that you're going to be working on is going to be, because the printer works in layers in the same way that a traditional printer would work. It's just that the layers are much thicker and you can sort of expand more in terms of like how high and how wide you want your object to be. Okay, but before we get into the actual printing, we have to consider using like design software. So I assume that some of you are designers and you might have been exposed to some design softwares that we might use. But there's some things we need to consider in terms of trying to get a model that is sort of compatible with 3D printing. But I'll show you just now in a demo on like how you can create a model that's like a closed model. So you need to be able to create a model that doesn't have any holes in it, per se, in terms of like the form. So if you're building a cube, I'll just go on and into Blender. Okay. So per se, if you're building like a cube or like an object, this would be considered a closed mesh. So it doesn't have any holes. When you go into it, it doesn't really have any like open bits in a sense. But once you go ahead and like sort of delete a face or something like that, then when we try and print it, that's not really going to register or read in the print. You can have an open top or something like that, but when we try and export this, oh, okay, I don't know how big this is. It's probably too big. Let's scale it down. So when we're exporting our format, once we've exported that and open it on Cura, you'll still see. Okay, cool. There's some objects that we're going to be working with later on. Okay. Okay. Great. So try and see what happens. We have an object that is in a closed mass, closed form. The object. Super tiny. So scaling is important. It's really tiny. But we can always slice it later. And it's fine. Yeah, it's on uniform scale. Oh, okay. Yeah, it's not. So you can try and find that hole again. Right over there. Try and slice it. See, there's like a big chunk missing over there in the middle. I don't know if y'all can see it. Yeah. Well, firstly, the angle of the actual object is a bit too wide, but we'll discuss the angles much later on. But along the middle here, we had a hole while I was modeling it, tiny little hole, which sort of then jeopardized the entire model, which means that now it's going to be quite difficult for us to print. So it's super important to do quality control in terms of your models and whatever that it is that you want to print before even sending it over. Let's go back to the other side. While we're still here, we might as well discuss some of the other restrictions that you could sort of come across while designing. Okay, so I'm on Blender now. When I spoke about angles and sort of how wide or high an object can be, it's important to figure out the fact that let's say I wanted to print this object here. If you look at the base, it's really tiny here at the bottom. So it's going to be quite difficult to try and print something like this because as I said before, clay is a medium that comes out as a wet sort of slushy object or slushy medium, sorry. And if you're trying to print something like this, the printer would go around in layers and around in layers. And then when it gets to this point here, it will start sort of fall off because this bottom part here might not be solid enough to be able to hold all of the other layers at the bottom. So when you're slicing it, it's going to be quite difficult to be able to actually print it out as an object. And as we were having that short demo over there at the back on Cura, I'll show you this just now. I see something. Okay. So if you look at this ball here, I'm trying to print, there's some red marks that are present on here at the bottom. So these are some indicators that show that it could be quite difficult to print. If it was a traditional printer, you would be able to add support onto the base of your object so that you can be able to print the whole solid object. And even if it has that little hole over there, you'd be able to add some sort of support for it to be held up. But since we're working with the ceramic 3D printer, it's almost impossible to add, well, it's impossible to add support while the printer is printing. you could add like a sort of like a scaffolding object that could hold that up. But I think the objective and the point is that the machine does most, if not all, of the work. So if we have to keep adding little scaffolds over there and over there and over there, so that this doesn't fall over, it's going to be, it sort of takes away from the point of like doing 3D printing and having this object that you built and then having it printed per se. So that's also something that's important to sort of think about. Going to slides. So I have another object over here that had a few issues. This one. I'll just show you this one here. And then this one as well. This is an object with some texture on it. The base usually has the redness or the red marks, which indicates that the printer is going to have a hard time trying to print it. But some of these little details over here at the back as well might have it. For this one here, it's not necessarily going to be a huge problem since it's very like small parts of it which are going to be strained, because when the printer is printing, let's just slice that. We're going to be able to, it's going to be able to stand on its own. See that there. But when you go into the top, we have an issue because the conference at that angle. So what the printer does is try to actually print the top parts, even though it can't print at an angle that's so steep. And what's going to happen is that it's going to try and almost like cave in on itself, or rather the material is going to start to cave in this middle area, and that could also affect your design. So angles at the base, or rather the steepness of your object at the base, is important to consider, like going this way. Yeah. And also the steepness at the top. So if you have an object that tilts to the side, some examples are full of interest, just choose a great source. Wait. Can you guys, can you see the presentation? Are you seeing the presentation? Okay. So something like this, which is quite fun and interesting looking, but you can start to sort of think of like the way in which it will fall over and how the printer will interact with an object like this, in a sense. So in areas, do I have a pointer? There. So in that area, maybe, for instance, you can see how that's quite steeply like coming off of like the actual form itself. So that might be a difficult thing to print because of how steep that spout is coming off over there. And maybe here at the back as well, might be a bit. Also, it's important to consider the warts and layers. So this bottom part here, it will print all the way and then it will sort of like we'll stop here and then try to wait to the top of it. Also would have a hard time. Essentially, prints would have the printer would then it wouldn't. It's also something like some sort of scaffold or like a way of like holding it up, but that would be quite. It would go on. Then like a form of like a. Okay. With this one, you could be able to put some sort of scaffolding over here. It up using demonstration and see some objects we used sort of like in itself. Similar response with in China prints and objects at once. This would be something like from the actual, yeah. Do we have a demo and how that works? We'll be printing a few of the above and try because it's hard to just on the computer screen. So I'll be so I'm going to send this over to the other prints. It's finished. Finished. But does anyone have questions in terms of like some design ideas that can,
Still showing.
no. I'm trying to get. So I'm done with this part of the presentation. Yeah, just the design restrictions.
Okay. So the designing obviously is a whole nother lesson and not something that we can teach in one sitting. But I want to go through some of the tools and explain how to think about the designing. So I'm hoping that the screen share is quite clear. Unable to start your video. This host has stopped it. Host, can you start my video, please? And so there's a certain software that I'm going to introduce you to called Openscad. Okay, so if you go to your browser and you type in, does anyone know how to move this little zoom bar so that it gets out the way? It's right now blocking me. So I can't access the toolbar because this zoom bar is in my way. Hard floating menu controls. Okay, so if we go to www.openscad.com, you will, whoops, Openscad, not .com, .org. This is a type of software that allows you to model using programming. So it's very different from all the other modeling software, which uses tools to make objects. This uses code. So you can download it, and then you can go and you can download some sample files as well to get you started. And if you go to the website and you go to 3D ceramic tutorial, you'll be able to find links to the software. And you can download the software, and you can also download an object or a sample file. So when you click on that, it'll send you to Thingiverse, and there's a guy here called Hicks who shared a file, which is quite handy. And you want the Openscad or the SCAD file. You just download that to your computer. And there's quite a few different SCAD files on the internet and Thingiverse. And the beauty of them is that you can customize the object however you want. So I'm going to go and open an example. And here you can see a vase that has been rendered on my screen. And on the left-hand side, you can see all the different options. So one of them is, do I want it to look like a vase, or I'm going to go for a cylinder because that's what I feel like. Let's try to spell it correctly. And then when I click this button, I can re-render it as a cylinder. And you can see these artifacts in here. Those can be changed somewhere on the side here. So if I click 4, I'm expecting 4 of those artifacts. How many do I want horizontally? So you could play around and get a completely different looking object from the one that you start with, as you can see. And that allows you to play around and come up with an object that suits you, whatever you have in mind. And that is one of the example files. And the one that I linked to would be this one here. So here you can quite easily set the diameter of the top, the bottom, and the middle. And that is where we're going to go for this lesson. So you're going to give yourself within the constraints that Sam gave us, which was 100 by 100 by 100, or basically 1 liter volume. You can play around with that, make it say 70 by 70 by 150. And let's say you wanted to have a bulge in the middle. So you're going to start it off at 60 and you're going to bulge out to 90 and you come back into 70. And when you then render it, you're going to see that it has got a general bulge to it. Now, in this case, it's got 4 sides, which I don't like. I'd like more than that. And so I'm going to go and change that here. And that's because the angle is 90. I'll change it to 45. Okay, so 90 was the twist. And you can play around here as you feel. I'm getting some warnings on that change there. And then, so this is, somebody's created this code. You can see the code there, quite complicated. I don't understand it. I haven't thought about the maths of it, but he has spent a lot of time designing that. And what that just allows you to do is play around. So we don't want a vase because we actually make it solid and then we turn it into a vase when we slice it. Capitals are important when it comes to code. So there we go. Do I want a double spiral? Yes, I do. Now it's going to have 2 spirals, and then this is going to be 150 mils high. How many layers do I want? Now, in this case, layers are different to the slicing layers. He's, in his code, is building this object through layers that he is defining. And so you'll see if we choose a few layers, we're going to get a very sort of going to the Minecraft type of object, which is actually kind of cool and classic. But if we want more resolution, then we're going to give it more layers. And although it's the same object, it's rendered differently. And then the angle is going to also define how much twist it has and how it's going to look. So that's just play around until you get something you like. So that's kind of a cool object. It'll look quite nice, 3D printed. See if we can get a few more edges. Okay, so I think that's kind of cool. I like that. And it'd be quite a nice planter. I think the only thing is I'd like the base to be a bit smaller. And then I'd like it to be more tapered. So if I go 50, 75, and 90, you get a more of a tapered look. I think I like that better. Again, you can play around. Now, if you go and you make the base, let's say 10, you're going to get a very, very small base, and you're going to get a big undercut here. And what's going to happen when you try and print this is you're going to have so little clay holding here at the bottom that the whole thing will collapse and fall down. You have so much weight on the top and so little surface area to hold that weight. So that is one of the things you have to bear in mind in terms of your constraints. So I think that would make quite a classic little vase, and maybe a little bit more delicate. Let's go 65. And let's see, just to give it a bit more elongation. Yeah, so that could be quite nice. And then we're going to get some interesting effects when we try and print this, because the contours are going to follow. It's actually going to be quite blocky. So I'm going to change this to 100 layers. And that's going to give me a bit of more of a resolution. So now, in order to get this as a file, I now need to press F6, which is going to render it. And the rendering process will be down on the bottom, and this is going to take a while. But when that's ready, we'll then export it as an STL file, and we'll then be able to import that STL file into the slicing software. So while that's rendering, I'm going to show you another way you can create something. Again, assuming you're a designer and you've got your own skills and your own software that you prefer, whether it's architectural software or freeform software or sculpture, whatever, on digital sculpturing, there's a number of different options. So when it comes to which tool to use, I've explained to someone before that you want to have different tools for different purposes. So we just use that what we call programmetric software, where we can change variables and things change automatically. Now, if we want to twist something and we want to object, let's say hexagon, we're going to have a base of, the radius of the base 30, which makes the base 60. I then can pull this up, make the height, let's say, it was about 40. Let's just go up to, let's redo that. Redo that one more time. So I'm going 6-sided, 30 mil radius, pull this up to 100 mils. Okay, and now I've got a very simple object. So now one of the cool things I could do is I could scale the top, which is going to give me some kind of tapering effect. So if I scale the top by 1.2, it only scales from one corner, unfortunately. I don't know how to do this from both corners. I'm not an expert in this software. But if I go now to the rotate function and I choose to rotate this object, let's say I rotate it 45 degrees, I've now got a twisted vase type object, which is quite neat. And so I want to try and go even more extreme than that. Too far, this is going to break. I think that's about as good as it's going to get. What else can I do? I could offset this outside inset it. I could, you know, extrude it back up. I could build it in little layers and rotate. So let me go back to this one. Let's say I extrude it to down to some random amount because I lost control there. Okay, and then this one I'm going to let's say going to extrude 20. I'm going to twist this one. And then I can extrude this up, another 20. And then I can twist it again the other way. Another 20, and this time I'm going to scale it. And this is pretty much how we designed our first cup that is now, I won't say it's famous, but it's quite kind of published because, okay, and you can see I've got this kind of weird kind of object. And so that's what the SketchUp software can do for you. Allows you to scale the whole thing down, squash it down a bit. And I can then export that. There's a plugin you've got to download. One thing I'm going to find is I'm going to have all these layers. If I delete this top layer and look inside and make sure that's, okay, the object does look, it looks pretty good. Just for that one face, we don't want any hidden faces in there because one thing the software is bad at is making solids. So that's now water type, and then I can save that as an STL, export as STL, export it, and call it cup demo 1.stl. Okay, and that is now done. So close SketchUp. I won't save that, it's not worth saving. And then there's also an online option. So if we look online, we can go to a program called Tinkercad, and that'll allow us to also do things. And yeah, I've got a whole lot of primitive objects that I can import. So you saw Sam do sort of a geodesic kind of object. You can just pull something like that right in, and you've got it ready to go. Icosahedron, and you could then stretch that up, play with it a little bit. And what's nice about this is you can use two objects and help them to interact with each other. And there's a whole tutorial you can do if you're interested in this subject, object and software. I'm not going to reinvent the wheel here, but I just want to show you what it's good at. So it's good at very quickly using primitive objects to create shapes. So there's no way Sam would have done that quicker in Blender, but she certainly would have more control over the object. So I'm limited now as to what I can do next because of the way this software works, this online software. But still, it's useful for its own purposes when you want to do something simple and quick. It definitely has its place. There's a reason why we recommend it is because you got to know what different tools do what. You know? Just don't be a one-trick pony. And one thing you do find with Tinkercad is that it's online, so it does sometimes bomb out. Okay, so the progress here is close to being done on the render. In the meantime, Tinkercad has decided to do it freeze. And so I'm just going to show you a little bit of the application of ceramic 3D. Okay, so let's just go through what's possible and just the market for these products. So here's some really nice objects made in Hicks. He's done 350 sales. He's selling his objects for what's that, 660, probably like $40 each. They look really nice, simple, elegant, and he's obviously got some skills there. He's glazing them. The inside have got no lines. The outside have still got some texture. You can see he's got a very similar setup to us. So that's one example, like his work. I'm just showing you commercial applications of people using this already and selling objects. Sassy 3D is doing some colorful stuff. Ceramic Glitch has got some pretty simple classic stuff they're doing. We've got this one here. We've got someone else doing something else, and here's slightly more kind of sculptural style objects. And then this Oliver van Herp is sort of one of the fathers of this whole ceramic 3D printing movement. So he built his own ceramic printer, and he's done a lot of work, and he's internationally kind of known for his work in ceramic 3D printing. We quite like his style of just a bare clay. And you can see he's also got lots of objects, the textures. So he's one of our inspirations. There's a whole article on there, Design. And then here's more sculptural applications. So playing with architectural panels and what could be done with 3D printing. Most of this is conceptual. I think it's 2 or 3 years old already. And then James Clark Hicks, he's a researcher in Canada. Really likes some of his work. He's doing some a lot of lighting, working with designers in the university, and just also pushing some of the boundaries with ceramic 3D printing. And he's doing a lot of algorithmic programming. So he is programming using a algorithmic method, which takes an object and then breaks it down and allows them to do a lot of interesting things with the G code. Okay, if we go back to Openscad, I heard a little noise, which means that the object is done. And there is the rendered object. So now I can simply export this as a STL. You just click the button here, STL button, and it's going to give me the option to export that as an STL. Okay, so again, I'm done with Openscad. I'll close that. Save those. And now I'm going to import them in for your viewing pleasure. And we have Akira, which is a slicing software set up for the ceramic 3D printer, which is quite low resolution compared to some of the regular setups. So the last vase, I'll just quickly import that. And there you can see the object. And I'm going to preview this with my standard settings. And this will show you how the printer is thinking about this object. So it's going to do 3 layers, 4 layers of base, and then it's going to print the outside layer. And I think this will be quite a nice object. So I'm quite happy to go ahead and print that. And the estimated time is 24 minutes. Depending on the print speed, we sometimes have to slow it down a little bit. So let's say this is half an hour. We price the printer for contract printing on an hourly rate. So this would probably cost you about $20 to produce. And then you can obviously sell it for whatever you can. So that would be an example. And then I'm also going to then import a that cup that I did in the SketchUp software looks fairly ugly. And there you can see the way that it looks and how it would print as a cup. This one is thinking it's going to take 11 minutes. These cups normally take more like 15 minutes, but yeah, close enough. And yeah, it's going to make for an interesting form. Okay, so I'm just going to walk over to our kind of demo area to show you some of what we have. So Simba, if you can just put the screen share off and focus on my camera. All right. Do you want to just focus on the printer? Okay, so let me take you through the genesis of 3D. Feel like I need a little stand here. Okay, that'll work. All right, so this is the first object that we ever printed. And it's a funny little thing, but this was literally our first fired object in the batch of our first fired object. And we hadn't figured out the base yet, so that was that. Next, we printed the classic cup. We didn't print them as finely and delicately as we have got now. And we've ended up with kind of a satin tough finish. And we did a little bit of coloring in the glaze just to make it interesting. And that was very similar to that object that I showed on SketchUp. We then played with some simple terracotta, which we found to be quite a nice clay, and we quite like it. So we've done a lot of work with terracotta clay. Worked with some other designers to try some new things. In this case, this object actually collapsed on itself. And so it was taller, supposed to be taller, but it still created a very interesting and quite a beautiful form. One of the guys we worked with was interested in how we could integrate handles into the design. So it's printed in one thing, which is also very interesting and quite nice. We experimented with the whole idea of these like loops that you see online quite a bit, which work pretty well. They're very delicate though, so they break off quite easily. This one hasn't really been glazed, so it's still kind of a write-off. And then we've started to work. This one is a very thick print, playing with a design studio from Scotland and looking at really accentuating the 3D printing as opposed to trying to minimize it. So that's quite an interesting experiment we're busy with. This is James from Canada that I talked about a bit earlier. So this object, the program, the algorithm starts to increase the kind of weaving pattern as it gets higher up. The more it gets higher up, the more accentuated it gets. And that was an object that was designed in collaboration with the designer in Cape Town. Then, sometimes the best objects are just the simple ones. So I think this is quite a beautiful form. We quite like just that simple classic finish, and I think that's got a lot of value. So less is more sometimes. Here we're playing with some sort of artifacts on the surface, working in collaboration with the designer from Austria. And I think we're gonna continue with this. These are all bisque fired. This is actually colored clay. So we've started to add some pigments to the clay to see what effects we can get. So if you look at the difference in the tone of these are three of the same earthenware clay, but this one has a white earthenware, this one is lower fired, and this one is higher fired temperatures. We experiment with some texturing using some modifiers in the slicing software to create these kind of fuzzy type of finishes. Some people really enjoy that look. Again, some kind of simple geometric, just plays with the eye and creates an interesting form. Here we've got some kind of light fitting experiments, which is also quite interesting, and the sort of light could be quite, the light that comes off could be quite nice. Here we're experimenting with having support for an overhang. It's modeled just as a block, so the printer doesn't realize that it's printing in midair, and the hand and these parts fall onto a solid block object and create like quite a delicate and interesting kind of bird's nest. We always think it reminds us of feathers, and again, kind of a classic shape. And then here's another example of a sort of integrated handle, which would then, I don't know how practical that is, but nice experiments in terms of a water jug and a little bit of color variation here. And then the more sort of sculptural and bolder kind of objects, which probably will carry more value in the market. So we kind of been working on that. Sam's been doing a lot of work on that. So I think that is the showcase. Back over to the printer now.
Okay, host. Oh, I'm sorry. Okay, so I'm gonna walk you guys through the process of actually slicing an object after we've gotten it from either a client or this time, in this case, it's one of the participants that are in-house here at the MakerSpace. So I'll just share my screen for a second and we'll do that process. Okay, so I think we're waiting for one of the objects that was made just now. So while we were having the presentation, my email. Okay. Okay, so I'll be slicing this object and walking you through the process of what we do from getting an object as an STL file. Okay, so this is from Diffit. Yeah. But it's one of the people who are here. And we're going to have the object printed. Okay, to make sure that it's centralized to the plate. I want to be able to see it and analyze it. Okay, looks good. There's a few red specks, but I think it's mainly because Openscad is software that works with like layers itself. So the printer is reading it as a full or like a whole object, but some of the areas where it seems like it's flat, so it's like a layered effect, might give it some glitches, but we'll have a slice and have a look at it. So let's analyze the object a bit. So you see a bit of that redness, but it's kind of negligible because I think it's part of how the software works in layers. If you get closer, you can actually see how the layers are built up. As Steve has demonstrated how Openscad works and sort of like these different small layers in a similar way in which the actual slicer would slice the object. So scale, I think I'm gonna give that a solid number instead. So it's nice and clean. Okay, perfect notation. Okay, and then we need to check some of these settings here. So for this object here, what we can do is a 1 mil layer height. So essentially when the printer is slicing it, we're gonna have layer heights of like 1 mil. And the width of the entire object is gonna be at about 3 mils. Okay, let's check some of the layers. Bottom. So we do neglect some of the options that are here, like sort of like the heating options or support options, as I said, which is something that you would, if you're using a traditional printer, you would add on as you're printing. So everything looks good. So I'll be slicing it just now. Okay, it's going to take 3 minutes. Oh, okay, let's put this back. What happened there? Slice it again. I think it might be the scaling. Let me just go back to prepare. Okay, I'm going to slice it again. Okay, it's having some issues with the printer. So
There's something wrong with the model. I'm gonna try and fix it. I think it might be all these little layers over here that are like individual layers, but I'm not sure why. Preview again. Let's change the layer height and see if that affects anything. It's not showing up. That's showing up as just 3 layers. I'm not sure if, I think it might be one of these red dots that are over here. So it's not reading the height of it. I think when we're probably using Openscad, since it's a layering system, you would want to have the layers that you're making to be the same size as the layers of the printer, so that the printer can understand how to sort of slice it and go through, so it won't have any hiccups. Then we have another object from Openscad that we made. I'll just put that on there. I think it was by coincidence that it has layers that are exactly the same in terms of like corresponding with the printer. Let's slice this object and see what happens. Okay. How much time is that going to take? 17 minutes. So it sliced quite perfectly. It's an object that we got from Kevin. He's also here for the demonstration. So that sliced pretty much perfectly. If you have any questions, you can just drop them down by the chat. I have a few questions as to why that other one didn't slice, but I guess we'll have to figure that out. Getting distracted. Is my audio breaking? I don't know if this is an old chat. Oh, okay, it's fine then. Let's have a look at the other objects. That's not like, but essentially once this process is complete and we understand that this is, I don't know how well this is going to twist, but it will probably, because we live in a world with gravity, this will probably sort of shift downwards a little bit when it's printing. But we'll see. Let's print this. Gravity will do its thing and work its magic and have it sort of slightly shifting down. Okay, cool. Let's export it. I've saved it. Stop sharing. We're gonna pause that print and have a look at how this one prints. Oh, I forgot what I named it. Not 1A. Okay. I'll be moving over to the printer just now. It's my absent.
That's what we want. Maybe that's not.
Shades of it. Yeah. You know what I mean?
Okay.
But mixing the two together doesn't necessarily mean you're going to get the exact same color that you mix with.
So I'm gonna go off the headset. Yeah. Okay, so we now on this mic, so it should pick up the talking that we're doing here. So Kev, I'm gonna ask you for your assistance. So you've been part of this thing. Okay, so this is the glazing part of the demo. So Sam's explained how to slice. We've done a little bit of background of design and your constraints. And now we're going to talk about the glazing. So how do we glaze the objects? Okay, so understanding when the object is printed, it is in its green form. It's very brittle. It can be broken with your hands without any trouble at all. So you've got to treat it very carefully. You've got to leave it for 2 days to dry out so that it's got no more moisture. You put it in the kiln goes up to 1050 degrees. You put it in the kiln with moisture in it. What happens is the moisture firstly expands out, so it's going to crack. And secondly, the moisture actually fuses to the ceramic over like 500 or 600 degrees. There's a whole chemistry issue and stuff goes bad. So anyway, you can't have moisture in the clay. So you let it dry for 2 days at least, and then you put it in a low speed ramp so that it can dry out in the clay even more, in the kiln completely dry, and then it will fire up to 1050 degrees, at which stage the chemistry of the clay changes and it fuses together, it becomes like a glass sort of pottery ceramic. And at that point, it's very hard. And that's great, and it gives you that very raw kind of look, which is cool. But if you're looking at earthenware, it's porous, meaning the water can go right through it. You know, so it will leak in a way. Terracotta earthenware is actually a great filter, so you could use it to actually filter water. You put water in, and water would drip out the bottom. It's been used for hundreds and thousands of years to filter water. So it's got certain properties, great for pot plants, but also you don't necessarily want the pot plant to leak out the bottom. So we do things like this where we glaze the bottom, and we can't glaze the actual bottom because that would fuse to the kiln. So we put a layer of glaze on the inside, and you can see that dark line, that's where the glaze is, and the lighter is where it's not. So you put soil in here, you put a plant in here, the moisture can't go past that line, but any moisture in the soil can evaporate out the side, meaning that you won't get root rots. You know, your plant will survive quite nicely. So that's about. So obviously you glaze things. Okay, so glazing is going to give you a shiny finish. Okay, so if you can just give me a bisque-fired cup like of this design top, just any random sample, and then we can queue up a few more examples of some of the different glazes we've done. I know we've got these ones. Any other ones you think we want to add that are on that display area?
Which way?
In that range there to showcase something that isn't already here. Okay, so here is the
I'm going to just use this as a light. Okay, so here we have bisque fired, glazed. You can see it's shiny, and here we have bisque fired. It's quite coarse. Look, it's quite a what's the word?
Speckled.
Yeah, it's
porous. Yeah, porous and rough.
Yeah, porous and rough. So
Yeah.
it won't work as a cup. It will absorb dirt. It will absorb whatever other stuff. So this will work as a cup, and that's why we glaze these. And that's that. Okay, so that's a clear glaze, quite thick. So
Cobalt.
yeah, then we got some oxides. We'll talk about that just now. What about the sort of satin? Is that kind of
No.
that's closer to the kind of classic finish that we're kind of going for now. We realize that that's the best thing is to just be a little bit understated and not try and be too crazy. Do we have any other colored ones that we can talk about? Here's just sort of experimenting with glazing and trying to.
It's a bit dirty. This is a cracked one.
Yeah, that one's perfect. So here's an example of too much moisture. So we had a crack, and there is a clear, transparent medium mixed with yellow stain. Okay, and so that is fused in there. It's glass. It melts and goes as glass, and nice vibrant color. And we kept the outside sort of that satin look. So there is a slight transparent glaze, but not overly glazed, but enough to seal it. And so you can see there is our object. So that's glazing the inside. Then we start to look at, so we got some stains. Yes, there's a pink stain, sort of brushed on, doesn't look very good. Then we go for the dipping. So with dipping, you get a much more consistent finish. Dipping, what did we dip here? Okay, I'm trying to find some good examples, but I don't have any here. So let me talk a little bit about the oxide. So that's cobalt oxide, which gives a very dark blue. And again, not an expert job. That's early days of glazing. Then here's quite an interesting copper oxide glaze on the interior, and then just raw on the outside, which is interesting. Here's a iron oxide, which goes very dark red, like an ox blood. And here's just a black glaze, standard black. This is really nice. This is a copper oxide in a transparent glaze, which came out very nice, like a satin black, very like metallic, very masculine and awesome. We still jury's out on whether it's safe to drink out of that, so we'll leave that for the plants. So yeah, what else can I say about glazing? Here's a copper cobalt, which went weird and bubbled, and here's a blue stain with no glaze, so that literally comes off, so it's not actually glazed. So that's some of the options. The bronze, it's a gold luster, but it comes out kind of bronze and metallic. That's kind of our favorite combination with the terracotta. So we're using that quite a bit, as you can see. Sort of complements the raw finish of the terracotta, and less is more, as we often find. So I think that's where you can specify your glaze color, and we will then try to execute as best as we can. So it's got to be fired twice in the oven, once at 1050 degrees, and then another time at 1070 degrees. Okay. So what's next? Kev, you were doing a great job before I interrupted you.
No.
What else? Just glazing. So
I could tell them about the stain part. Yeah.
You mixing stain with
With
medium.
clear, no, not medium. With clear glaze.
Clear glaze medium.
Yes.
Okay, paint on. Paint on.
Yes, paint on.
Okay, so I did speak to the lady and she said the reason we're getting that pulling away is because it's too thick.
Yes.
Okay, so she said,
So how do we thin the how do we make this? You see, when we do this here, check that there, it's quite
thick.
thick. So we're obviously taking that and mixing it with the stain, but how do we make this runnier?
I don't know if we did this with, I don't know what we used for this.
That was the very first, no, we probably
It's a
did do
medium.
it. We did use the medium.
So you just got to be careful, make sure you get it everywhere. And
Yeah,
it
but the
pulls away.
medium we only use when we do the,
See, this one dipped and came out perfect.
yeah,
See what it-
yeah. This, we gotta find, like, if there was a way to find a slightly thinner glaze,
We mix our own medium.
then we mix our own medium. That's the only way to do it, yeah.
Right, so you're using the blue. Okay, you done with yours. You're gonna do another coat.
No, I want to do a clear glaze on the inside. So when the chaps are all
It's a-
finished there, check what Diff did. No, I made a bit of a mess, but it's quite clever because we've been battling to the top section. He just painted it that way. So
Yeah.
yeah,
You wanna do a clear glaze?
yeah.
Just mix this up.
So clear glaze on the inside.
Just, oh, she said the glaze is too thick. And it's really together.
And that also, the clear glaze that you get, the transparent clear glaze gives you a much more shinier look. The one that you got there gives you a very matte look. Satin look. No, that was what Lily did. My
Yeah.
daughter. That's
I
the
just
thing.
want to see what the pink would look like. with this
Yeah.
color.
But the pink actually, that was, I made a cock up there. I'd mixed water and transparent glaze and
Yeah.
yeah. Do you want me to get my hands in this and get it all nice and squidgy?
Hey guys, still live? Hey guys.
All good, all good. Yeah, how big is the machine? It's very large. So you need the whole space. Maybe just ask Steve about that first. But the guys won't be too long.
You see? Will you please give, you say Graven? Graven.
Hi, you see.
You see?
Hi, you see. Hi, you good, good.
So give Graven a tour
Yeah, please.
and then just give him a rundown of towards employment, which is one of the things that.
You guys are good to school for the China. Children come out of the country.
Okay, you get that glaze.
So it's really nice.
Section, yeah.
So what's that?
Yeah.
What can the IT system, I want to see today. So, 98, so. And I get the city. Then you just sit in the middle of the somewhere. They got to what do they do? So what's trying to.
Let me get there. Because you don't see.
In the homes, in the homes.
Yeah.
I just decided it would be its own thing.
Well, it's still,
You know, they might have lost one.
yeah. I can't dig it.
Yeah.
I like getting a tattoo.
I'm a creep.
So how? No, just.
You go and get Sam to teach you how to make objects 3D. Okay. We've been on that road. We've been down that road.
It's on a.
I don't know. I don't think it ends up being.
So
doesn't
put
end up
another
looking good.
car.
Yeah, I think it ends up looking like ugly. But it's your cup. See whatever you want.
Okay, you said she.
But where are you going? You're cleaning up. Okay, so I'm just mixing up clear glaze here. And you're going to dip in glaze and paint in glaze. Oh, so what we need is we need some
Yeah, got my
spray
video.
bottle with some alcohol.
I'm
Sanitizer.
there.
You got sanitizer?
We have it around here though.
We've got
Samsung 150 here. What?
spray bottle.
What's like Mary Poppins in the car, Brendan?
Okay. Oh no, open this. I'm gonna be safe. How? Where's my video? Okay. So we ran into a few issues when we were trying to print one of the designs that was shared to us, which is something that can be expected, and it's part of the process. And we have to sort of find new solutions for problems that we had never faced before. So when we got the object, came in with all these layers. He used Openscad to make the actual object. So it has these fine layers, which are like step-up layers that make up the form and the twist. But then when you try and slice it with the general settings, when you try and slice it with like the general settings, it doesn't actually show up. So something that's sliced, I'll give you a look just now. When you slice something, it comes in, put it in the bed and you slice it. And then when you preview it, it should have all these layers which convert to G-code for the machine to print. And if for the other object, you couldn't really get that. So what I had to do is let's bring it back in, try and get it at 0. Actually had to scale it up because each and every single one of those layers was scaled down by like a 0.1 percentile. So scale it up a little bit bigger. Now we slice it. It has all the layers fully done in. So now what we're going to do is actually have this exported so you can tell that it's been sliced properly when you can be able to see all the layers that the printer is going to be using. It's going to take an hour to print because it's slightly bigger, but it's not going to take a full hour, but it's going to take a bit longer. Let's just say that. No. Rename that. Yeah, I'll walk over just the printer just now and have it start printing. I'll teach you.
So can you get a camera on the guys doing the sound as well, just so that people can see there's people working? So your camera, your computer, turn it so that seeing those guys.
So like literally I have to register for that. I actually have to publish it Saturday. So that's what Tyson always does. So went to Casey, let's start and then we come to me for the Chris collective. I've been registered for the domain. And they say, we just started the agency. So this company. So yeah, because I'm making like on the job and I'm not going to take a bus from here out. Oh, they're all the same way. Well, not the same, but all stories. So I'm really like on the job, and I have a great job. Now you've got to come up with expenses for that. So last year we did, I started paying myself a salary. Just make expenses to the company. You don't pay yourself a salary. Yeah, it's the worst thing you can do, right? Because you have to pay your AUIE. So I'm also good. Like I'm literally like. Yeah. That's it. That's why you want to do. Yeah. Yeah. So now, the last 2 months. Yeah. 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 Yes. But it's still, you still have to pay it.
So, I don't know, you can also just you can negotiate on songs, you have to pay it all. Yeah.
You still have to pay it though.
Point is like you can't just get into a rhythm, it's just done. Yeah. That's good. Having it lurking is crazy.
Whole reason why we're here is to get away from that.
It's like cool. Hey, the whole thing's just been broadcast.
Where are we now? What's happening now? Is this mine done? I need a tea, Mr. Need a
Yeah.
sponge.
So the mic is loud.
Oh well.
creating sketch. And I have a sketch of what I'm supposed to do.
Introduce yourself,
call it-
Sophia.
I'm Fiso, in fact, the designer using Fusion. So I'm given a sketch to do in Fusion of 3 attached polygon,
Bring it closer. So that it's
of 3 attached polygon. So I already created the sketch on Fusion. So now I'm injecting polygon. I'm gonna get the dimension. Because we're still gonna scale it on Cura. So I made it 40. First one.
bit louder.
So I'm creating the next one.
Check the audio because I can't really speak with 2K.
I'm creating the second one. So I'll take edges, using edges. So there are different polygons you select on the menu. So I'm taking one with edges so I can mount the structure, the sketch on the other one. And I'm gonna still have the other one. Making copy. Yeah, now I'm gonna extrude into different heights as you see on the paper. So I'll make the other one. 20, 30. And the sketch has disappeared. So you have to go and open the sketch, like show up the sketch and do another extrusion with different heights. So make this one 50. And then the other one is red. Yeah, I think I'm done. Now I'm gonna export the STL file. Like a pivot.
Yeah.
Outside, connect to one.
Jump out.
Because you're gonna have to, if they have a thing, you're gonna have to fill in the section.
So now I'm gonna create like a soft edges, not a sharp one. So I'm gonna use fillet. And I'm selecting edges. Now I have to select like how much fillet I'm putting on the edges. So I'm putting two big. I'm gonna put 5. 10. 10 is better.
No, you pay for all of them. You're gonna pay for the inside one, so
Yeah, look at it. What month is it gonna print?
That's why we're testing the limit.
Right now.
Yeah.
and I see the constraint.
No, no, I
So
mean,
now
the
we're gonna
actual
select the set
certificate.
Like a step.
Yeah.
Go.
Done. Now I'm exporting the file as an XCL for some as a mesh. Now I'm setting the file. Just leave it.
Okay, so I'm about to share my screen and walk you through the process again on how we slice the object and see if there's any sort of issues we can point out from Cura itself. Okay, so I'm just going to pick up the file. Okay. Okay, so no red flags or no red outlines when we've gotten the print into Cura. So let's just try and slice it and see what happens. Okay, so that's the results we're getting. So as you can see, the print is going to try and print right from the bottom. It's 5 layers. It will go up, and then it's going to shed all the way from this point to that point over there because it sort of has reached the height limits for the first step up, and then it will go all the way up and sort of repeat the same process here. Well, this side here, it's going to have this gap over here. So if you can check this out, this is a solid plane, and that's a solid plane, that's a solid plane. But what the printer interprets is that this doesn't go all the way down. So it's going to be printed in sort of this sort of format. Okay, so let's try and check out the scale. Scaling is a bit too big. I'll give it 100. Well, actually, it's fine. Because it's 70 by 140, but everything needs to be by 100. So that's fine. It's a bit smaller, but still slices quite well. All the layers are going to print through. I don't know what this object is supposed to be. What is it supposed to be? I think it's supposed to be a candle holder of some sort. So it's going to be a very small little object to put your candles in. It's quite interesting and fun, and let's see. Yeah, it's a thingamajig. Okay, so just going to save it onto the drive and see how it comes out. Yeah, Okay. See so.
So yeah.
Sign off. Yeah. Okay, so featured video, Simba. Mute all things. Turn off the projector. I mean thing, yeah. Okay, guys, so that's been ceramic 3D printing workshop. And we just want to thank you guys for participating online. We've had a lot of fun and we've made some objects, and we'll be sending those objects out and glazing them, firing them, and get hold of us if you want to make your own objects. We're available to do production, custom production for designers. So yeah, check you guys soon.